So we have done distance versus time graphs, in which the slope of a graph graphs its speed, because speed is distance over time. And we've done position versus time graphs, in which the slope of the graph is its velocity, because velocity is change in position over time. So now we're doing velocity versus time graphs. And as you can probably guess, because velocity is, or because acceleration equals change in velocity over time, the slope of a velocity versus time graph equals its acceleration. So as we move through this, each line that you see represents acceleration, the red lines. So if we look at this first graph here, we just have a horizontal line. Is there any slope on that line? I want you to think about that. Is there a slope at all? Is there any steepness at all? There's not. So is there an acceleration then? Is there a change in velocity? Is velocity changing at all? No. And if velocity is not changing, then it's constant. So velocity is positive and constant. It's positive because it's in this region of the graph. This is our negative region down here. This is our positive region. So velocity is constant. It's not changing. There is a velocity if you look. Whatever this number is the velocity, but it's constant. So since velocity is constant, acceleration is equal to 0. If velocity isn't changing, then we don't have an acceleration. So here is another one that looks similar to our one before, but it's a little different. I want you to think what's different about this graph. Remember how I said up here this region represents positive velocity. This region down here represents negative velocity. The positive and negative here are just referring to direction. Okay, so since this red line's in the negative region, that means the velocity is moving in the negative direction. But as indicated by our lack of slope, we have a constant velocity again, except this time it's negative. And since we have a constant velocity, that creates 0 acceleration. Acceleration is change in velocity over time. If velocity is not changing, then there's no acceleration. Now in this next graph, we have positive region here. So velocity is moving in the positive direction. The motion is in the positive direction. And it starts here at 0, but then what's happening to the velocity as time increases? The velocity is increasing, right? So if velocity is increasing, what type of acceleration do we have? Positive or negative? We have positive acceleration. And again, you only have to write the highlighted stuff, but if you want to write more, you're more than welcome to. So here's our next one. And time is increasing. But what's happening to the velocity? We notice it's in the positive region, so we know velocity is moving in the positive direction. But is velocity increasing or decreasing? As you look at it, velocity starts up pretty high here in this positive region, and as time continues, velocity decreases. So when velocity decreases, is our acceleration positive or negative? acceleration is going to be negative. If we're slowing down, velocity is decreasing. Acceleration is negative. And if you look here, the slope is negative. And what does slope equal on a velocity versus time graph? Slope equals acceleration. So slope is negative. Velocity is decreasing while time is increasing. Our input is increasing, but our output is decreasing. So that's a negative slope. It's slowing down, which we know means a negative acceleration.